Good morning to all. I am G.LOKESHWARI, Assistant Professor of Computer Science, A.D.M. College for Women, NAGAPATTINAM. Now we are seeing the topic is mobile IP from mobile computing. What is IP? IP is an internet protocol. Then we are using in mobile IP is an internet engineering task force standard communication protocol that enhances the existing IP to accommodate mobility. Mobile IP allows mobile computers to stay connected to the internet regardless of their location and without having to continuously change their IP address. Every mobile user needs continuous network connectivity irrespective of his physical location. The traditional IP does not support user mobility. Mobile IP was created by extending IP to enable users to keep the same IP address while traveling to different networks. Advantages of mobile IP. It allows fast, continuous, low-cost access to corporate network in remote area where there is no public telephone system or cellular coverage. It supports a wide range of applications from internet access and email to e-commerce. Users can be permanently connected to their internet provider and charged only for the data packets that are sent and received. It can move from one type of medium to another type of medium without losing connectivity. Disadvantages of mobile IP. Routing inefficiency problem caused by the triangular routing formed by the home agent, correspondent host and the foreign agent. Security risks are the most important problem facing mobile IP. The problem in making mobile IP coexist with the security features within the internet. Requirements of mobile IP. First one is compatibility. What is meant by compatibility? A new standard cannot record changes for applications or network protocols already in use. Second one is transparency. Mobility should remain invisible for many higher layer protocols and applications. Third one is scalability and efficiency. Introducing a new mechanism into the internet must not degrade the efficiency of the network. Fourth one is security. All messages used to transmit information to another node about the location of a mobile node must be authenticated to protect against remote redirection attacks. Next topic, mobile IP entities and terminologies. Mobile node, the device that moves from home network to foreign network. The node that can change the point of connection to the network without changing its IP address. For example, laptops with antennas or mobile phones. Second one is home address. The permanent address of the mobile node in its original network, the IP address of mobile node. Next, home network. The original network of mobile node was associated with respect to its IP address before moving to new network. No mobile IP support is needed within the home network. Then fourth one is home agent. The system in the home network of the mobile node, typically a router, provides several services for the mobile node. First one is tunes IP datagram to the COA. Second one is maintains a location registry of MA. Then implementation of an HA, home agent. The implemented on a router that is responsible for the home network. Implemented on an arbitrary node in the subnet. Some disadvantages are there in implementation of HA. Double caching of the router, a packet for the mobile node comes in via the router. The home agent sends it through the tunnel which again crashes the router. The home agent could be again on the router, but this time only acting as a manager for mobile node belonging to a virtual home network. Then foreign agent, FA. The system in the current foreign network of the mobile node, typically a router. It can have COA. Then it provides several services to mobile node during its visit to the foreign network. Forward the tunnel datagram to the mobile agent, then it provides security services. The next one is foreign network. A new network that mobile node visits and which is not to the home network. That is called a foreign network. The next one is correspondent node, the communication partner. The correspondent node is called a communication partner. The node that wants to communicate with mobile node. At least one partner is needed for communication. The next one is care of address. Shortly it is known as COA. The new address of mobile node in the foreign network is called a care of address. Then there are two different possibilities for the location of the COA. The types of COA is, first one is foreign agent, another one is co-located COA. Then foreign agent means the static IP address of a foreign agent on a visited network. Then co-located COA means the temporary IP address assigned to the mobile node. It represents the current position of the mobile node on the foreign network and can be used by only one mobile node at a time. Then the co-located care of address, that means COA, can be obtained by dynamic host configuration protocol, that is shortly known as DHCP. Then IP packet delivery. How mobile IP works? The step 1, CN sends the packet to the IP address, that is home address of the mobile node. Then second step, the internet routes the packet to the router of the mobile node home network. Then the home agent examines the packet to find whether the mobile node is present in its current home network or not. If the mobile node is not present, then the home agent encapsulates the datagram in a new packet. Step 3, the encapsulated packet is tunneled to the foreign agent, which acts as a new destination address. Then the foreign agent performs decapsulation to remove the additional header. Then forwards the decapsulated packet to the mobile node. In step 4, the mobile node, after receiving the packet from CN, the forwards the replay packet to the CN by specifying its own IP address along with the address of the CN correspondent node. In this diagram, the steps are explained in the previous one. The home network, then router, then mobile node, internet and the router, the packet delivery to and from the mobile node. Next, the key mechanisms in mobile IP. The mobile IP operation stages, there are 3 stages are used in the mobile IP operation. First one is agent discovery, second one is registration, third one is tunneling and encapsulation. Then first one is agent discovery. The mobile node uses a discovery procedure to identify prospective home and foreign agents. There are the tasks the mobile node to determine the foreign agent or home agent. Both home agent and foreign agent periodically broadcast agent advertisement message. The mobile node must discover a home agent before it leaves to a home network. Second one, the mobile node must also discover a foreign agent after it moved to a foreign network. Uses of ICMP router discovery protocol. The ICMP router discovery protocol enables a host to broadcast or multicast to discover the IP address of their neighboring routes of foreign agent. The agent discovery methods, there are 2 agent discovery methods. First one is agent advertisement, second one is agent solicitation. Agent advertisement, these are the functions are included in the agent discovery. It allows the mobile node to find whether an agent is home agent or a foreign agent. If it is a foreign agent, then get the COA, case of address. It allows the mobile node to know the type of services provided by the foreign agent. It allows the mobile node to know about the allowed registration, lifetime or roaming period for visiting foreign network. These are the functions used in agent discovery. In this diagram, the packet format is centered in the agent advertisement. There are 2 parts, ICMP part and extension part. The ICMP part, the bits are calculated, the type 0 to 7, then code is 0 to 60, the address, the number of address advertised with this packet. Lifetime is calculated to length of the time the advertisement is valid or not. The preference, most eager router to get new node. The second part is extension part for mobility only. This type of function included in 16 bits. The length is depends on the COA, case of address provided with the message. Then the sequence number, then registration lifetime. The registration lifetime is calculated in maximum number of lifetime in a second in the node can request during registration. Then in this diagram we noted R, B, H, F, M, G, R, T. The explanation is R is registration, B busy, H home agent, F for foreign agent, M and G for methods of encapsulation and V for version. These are the agent advertisement in packet format. Then second function is agent solicitation. Rather than waiting for agent advertisement, a mobile node can send out an agent solicitation. This solicitation forces any agents on the link to immediately send an agent advertisement. If mobile node determines that it is connected to a foreign network, then it obtains a case of address. Then types of case of address. There are two types. First one is foreign agent, second one is co-located COA. Then foreign agent of case of address, the static IP address of a foreign agent on a visited network. Second one, co-located COA, the temporary IP address assigned to the mobile network. We are already known the topic. That represents the current position of the MN foreign network and can be used mobile node at a time. Then use the protocol is dynamic host configuration protocol. Then these are the steps followed in agent solicitation. Then mobile agent, these are the home agent and foreign agent. The broadcast agent advertisement message at regular interval. Then mobile node receiving the agent advertisement message, observe whether the message is from its own home agent and determine whether it is on the home network or the foreign network. The mobile node does not wish to wait for the periodic advertisement. It can send out agent solicitation message that will be responded by a mobile agent. After this type an advertisement or solicitation, the mobile node can now receive a COA, that is case of address, either one for a foreign agent or co-located to the COA. The mobile node knows its location, that is home network or foreign network, and the capabilities of the agent. Next step for the mobile node is the registration with the home agent if the mobile node is in the foreign network. Next topic is registration. If the mobile node discovers that it is on the home network, then it operates normally without mobile IP. Without mobile IP is without mobile internet protocol. I have the registration in mobile node. And if the mobile node has moved to a new network and obtained the case of address from a foreign agent, then this address should be registered with the home address. The registration process, the mobile node uses an authenticated registration procedure to inform the home agent of its case of address. The registration messages uses UDP protocol, user datagram protocol. We are using the registration, we are using the protocol via the UDP. The registration can be done in two different ways. The registration on the mobile node through a foreign agent. In this foreign agent, the COA how acts as the foreign agent. Mobile node sends its registration request containing the case of address to the foreign agent, which then forwards the request to the home agent. Now, home agent will do the mobility binding containing the mobile node's home IP address and the current COA. Then finally, the home agent acknowledged via foreign agent to mobile node. In this diagram, we are represents the registration of the mobile node through FA. Second one is directly with the home agent. If the COA is co-located, the mobile node sends the request directly to the home agent and vice versa. The registration procedure for mobile node is returning to the home network. In this diagram, we are seeing the directly with the home agent, then mobile node to home agent. The registration request is sent to the home agent, then respond to the mobile node. Registration process. The registration process involves the exchange of registration requests and registration replay messages. When the mobile node registers by using a foreign agent, the registration process takes the following steps, which is shown in the figure. The foreign network and the mobile node, then home agent. These are the processes are included. The first step is registration request. The second step is the registration request for IP of mobile node. Then third one is update mobility binding table. The fourth step is registration again replay. Then fifth one is visitors list. Who are all visitors? The updation could be stored in foreign agent, then sent to the mobile node, the registration replay. These are the process in foreign network to home agent, the data to be transferred. The mobile node travels to foreign network. It registered with the foreign agent by sending a registration request message which includes permanent IP address of the mobile node and IP address of the home agent. The foreign agent in turn performs the registration process on behalf of mobile node by sending the registration request message to the home agent, which includes permanent IP address of the mobile node and IP address of the FA. When the home agent receives the registration request, it updates the mobility binding table. Then the home agent sends an acknowledgement to the foreign agent, that is called a registration replay. Then the previous figure we have shown that the step 5 and 6, the foreign agent in turn updates its visitor list and replays the replay to the mobile node. Next concept is tunneling and encapsulation. What is meant by tunneling? The data transfer is called a tunneling. The mechanism used to forward IP datagrams from a home address to a care of address. That means sending a packet through a tunnel. That is data transferred to one packet sending to another one host. Then the tunnel establishes a virtual pipe for data packets between a tunnel entry and a tunnel endpoint. Entry to endpoint, they are sending the data to transfer. There are two primary functions. First one is encapsulation and second one is decapsulation. What is meant by encapsulation? The mechanism of taking a packet consisting of packet header and data and putting it into the data part of a new packet. The home agent encapsulates all the packets addressed to the mobile node and forward them to the foreign agent. This type of primary function is called encapsulation. The next one is decapsulation. The reverse operation, taking a packet out of data part of another packet. The foreign agent decapsulate all the packet addressed to the mobile node and forward them. The encapsulation is a reverse operation of decapsulation. These are the diagram denoted the original IP header, then original data. It's sent to the new IP header to the new data. Then last output is outer header to the inner header and original data. In this diagram, we can see the home agent, correspondent node and foreign agent, mobile node. How we are sending the tunneling and encapsulation and decapsulation? The corresponding node to home agent. The home agent sends the tunneling, that is data transfer to foreign agent. Then foreign agent sends the data to mobile node. The original IP packet is encapsulate the header and the payload and decapsulate the header and payload in CM and M1. The steps in encapsulation. Before we see the diagram, when a HA, that is home agents, receive a packet addressed to a mobile node, it forwards the packet to the case of address using IP. Within IP, this is called encapsulation. Suppose we are having using IP within IP, the home agents insert a new IP header in front of the IP header of any datagram. The destination address is set to the case of address. The source address is set to the home agent address. After stripping out the first header, the IP processes the packet again. There are different ways to performing the encapsulation. There are three types: IP in IP encapsulation, minimal encapsulation, then generic routing encapsulation. First one is IP in IP encapsulation. This is mandatory method for the mobile IP. The full IP header added to the original IP packet. Inner IP header source and destination address identify the original sender and the original receiver. The new outer header contains home agent address, the source and COS destination. This is called IP in IP encapsulation. In this diagram, we are seeing VAR, IHL, TOS, length, IP ID, TTL, IP in IP and IP checksum. Where VAR means IP protocol version number, IHL, internal header length, TOS, the type of service included in copied from inner header. The length is calculated in the packet is encapsulated in packet length. IP ID means whose flag is used, they used for fragmentation. TTL means time to live. Then IP in IP, the upper layer protocol. IP checks the error detection in the IP packets. Minimal encapsulation. It is an optional method for mobile IP. In IP, internet protocol and internet protocol, several fields are redundant, that is repeated. Minimum encapsulation will remove these redundancy. The repeated data are removed from minimal encapsulation. This method is optional method in mobile IP. In this diagram, we are seeing the type 55 is a redundant packet. If SBT is set, the original sender address of the CN is included in the packet, that is removed from the redundancy is removed from the minimal encapsulation. GRE, that is generic redundant encapsulation. The minimal encapsulation and IP in IP only works for IP, while GRE also supports other network layer protocols. It allows the encapsulation of packets of one protocol suite into the payload portion of a packet of another protocol suite. The packet of one protocol suite with the original packet header and the data is taken and a new GRE header is prepared. Then together this forms the new data part of the new packet is called a GRE. So this is the most important GRE encapsulation in encapsulation topic. Finally, the header of the second protocol source is put in front. The outer header is the standard IP header with a home agent as source address and COA as the destination address. In this diagram, we can see the final header of the second protocol is put in the front. The outer header is standard IP header with a home agent. The source address and COA as the destination address. In this diagram, we can see the GRE, generic redundancy encapsulation. Type is 47, then C for checksum, then R for it indicates if the offset and the routing fields are represented and the end contains valid information. Offset in bytes for the first source routing entry. The routing field, if present, has a variable length and contain fields for source routing. The key is used for authentication. The K bit is used for authentication key is present or not. S bit is used for the sequence number field is present. R is for recursion control field. This field represents a counter that shows the number of allowed recursive encapsulation. RSP means reserved for future use. It must be 0. Then version is 0 for the GRE version. Then layer 4 protocol for it specifies the protocol of the packet following the GRE header. The last topic is optimization. Optimization means one of the problem with the mobile IP is triangular routing. What is meant by triangular routing? An inefficient behavior of non-optimized mobile IP. The triangular is made of the 3 segments, that is CN to HA, HA to COA / MN, then MN back to CN. There are the 3 types of routing is followed in the triangular routing in mobile IP. To optimize the route, how we optimize? Enable direct notification to the CN and the home agent informs a sender about the location of mobile node. The direct tunneling from the CN to mobile node, the binding cache maintained at the CN, the binding cache which is part of the local routing table for the CN. The optimized mobile IP protocol needs 4 additional messages. First one is binding the request. Any node that wants to know the current location of the mobile node can send the binding request to the home agent. The home agent can check if the mobile node has allowed broadcasting of its current location. Then second one is binding update. This message sent by the home agent to the CN, it reveals the current location of the mobile node. The message contains the fixed IP address of the mobile node and the case of address. The binding update can request an acknowledgement also. Third one is binding acknowledgement. If we are requested, a node returns the acknowledgement after receiving the binding update message. Then the last one is binding warning. If a node decapsulates a packet from a mobile node, but it is not the current for an agent for this mobile node, this node sends a binding warning to the home agent of the mobile node. Reverse tunneling. What is meant by reverse tunneling? Tunneling means the data transfer. So reverse tunneling. Reverse tunneling is the tunneling from mobile host to mobile home agent and make it possible for the mobile host from foreign network to communication in the network is called a reverse tunneling. Thank you all.